looking at note 7, job 1, preferably without the unit circle, is to answer those 9 first quadrant unit circle trig ratios up there. So again, preferably without looking at the unit circle, answer sine of pi over 6, cosine of pi over 6, and so on. And again, if a quick sketch helps, nothing wrong with that. Let's see, there's pi over 6. Here's how I think of it. Sine is the y-coordinate. That's a short side, so that's 1/2. Cosine is the x-coordinate. That's the long side, so that's root 3 over 2. So finish those 9 real quick, and then we'll move on. All right, those should be pretty easy, those first quadrant angles. Again, if you need to draw a quick picture to sort of remind yourself, oh yeah, sine is the y-coordinate, it's the middle side, so it's root 2 over 2. Cosine is the x-coordinate, but they're the same because it's the 45, and then one of them over the other is 1. I think I mentioned this before. I do not want you drawing the full unit circle, but a lot of times on this test, students will sketch out the first quadrant and write those values out. Kind of get their brain thinking in terms of x's and y's and cosines and sines and over 6, over 4, over 3, and so on. And so that is helpful. That gets your brain kind of going in the right direction. And then, again, don't draw out the whole thing, but maybe the first quadrant's helpful. All right, what we did not do yesterday, what we will do today is these reciprocal functions. So what is cosecant? What's cosecant? Okay, that's not how I was going to say it, but it's a lot of things. That's one way you could say it. How did you know it was hypotenuse over opposite?
Because sine is opposite of hypotenuse.
So probably the most important thing to remember is that it's the flip of sine. So SOHCAHTOA, and then grab the SO and flip it over, and you get H over O. The sine is the y-coordinate, so another way to say this is you flip the y. Just flip it over. 1 over maybe even is misleading because all you got to do is, they're already in fraction form, all the answers are, flip it over. So again, that's like 4 different ways to think of cosecant that are all saying the same thing. Flip the y-coordinate. Secant is partners with cosine. It's the flip of cosine. So 1 over cosine, or just 1 over the x-coordinate. Flip the x-coordinate over. Cotangent is the flip of tangent. That's how I think of it. Tangent is y over x, so cotangent is x over y. So let's do a couple of these. Cosecant of pi over 6. So I want the flip of the sine of pi over 6. And again, for these first few, I'm going to write like all of my thought processes. Once you've done some of these, you're going to stop writing them out. You're just going to start thinking and flipping and going places on the unit circle, and that's fine. Okay, pi over 6 is right there. The sine of it is the y-coordinate. So that's 1/2, but I need to flip it, and if I flip 1/2, I get 2. Again, the more practice you get on these, you'll get a lot quicker at these, and you'll be flipping things super fast. Rather than working across, let's work down because it's also pi over 6, so my picture still works. So I'll use that same picture, but for secant, I want to flip the cosine. Well, the cosine is root 3 over 2. It's the long side, so it's root 3 over 2. If I flip that, I get 2 over root 3, and then I need to fix that, so that's 2 root 3 over 3. Let's see. All right, let's do the pi over 3s. So that's the steep angle, Cosecant is the flip of sine. Sine is the y value. That's the long side. So if I flip it, don't forget to flip it. A lot of times that's the problem in the end. People forget to flip. And then fix it. 2 root 3 over 3. And again, at some point you stop drawing pictures and writing flips. You just see secant and your brain thinks, okay, flip the cosine. Pi over 3. Cosine of pi over 3 is a half. And if I flip that over, I get 2. And so hopefully it starts to speed up. And obviously the more familiar you are with the unit circle, the faster they go. It's not a race, but we also don't want to take forever and draw out every picture and write out every single step. Cotangent. Okay, that's the flip of tangent. The tangent 3 trick tells me that the tangent of pi over 3 is the square root of 3. But I need to flip that over to get to cotangent. And then multiply top and bottom by square root of 3. And I get root 3 over 3. And I wouldn't memorize any of the secant, cosecant, cotangent. You memorize sine, cosine, and tangent, and then you just flip it when you need to. Cotangent pi over 6. So that's the flip of tangent of pi over 6. So I need to flip root 3 over 3, which would be 3 over root 3. This one, you start showing all your steps, and it looks crazy. And all of that eventually becomes the square root of 3. Did that too fast? It's the flip of the tangent. Tangent's root 3 over 3. Flip it over, fix it, you end up with square root of 3. And I guess the trick is the deeper down this hole you go, and the more steps you have to do in your head. Some of you don't want to write anything down, and then you start missing them if we get too crazy with our questions. Okay, pi over 4, that's the one in the middle. So I need to flip the sign. The sign is root 2 over 2. So I flip that over. I get 2 over root 2. But then I have to fix it. And what's 2 root 2 over 2? Yeah, but there's a better way to write 2 root 2 over 2. Root 2. We were doing a multiple choice thing yesterday, and a student was like, Mr. Wolf, I don't see this as my answer, but I'm pretty sure it's right. I was like, yes, that is correct. Do one more step with that. And he's like, oh, yeah, sorry, root 2. Secant pi over 4, that'd be the flip of the cosine, but that's going to be the same thing as the secant of pi over 4, so just root 2. Again, the more of the connections you make, the quicker it goes. Cotangent pi over 4, that's the flip of the tangent of pi over 4. Oh, this throws people off sometimes. What do you get when you flip 1? 1. And you turn 1 over and you still got 1. All right, you do 1, 2, and 3, and then I'm gonna start pulling popsicle sticks here. It's enough of me talking. Time for you to talk. Show as much work as you need to show to get the question right. Again, on the test, there's 20 of these. There's no partial credit, so you're not showing work to get credit. You're showing work to help you get the right answer. All right, 4, 5, and 6, and I'll pull 3 more lucky winners. There's 4, 5, 6. Next do 7, 8, 9. So it's negative root 2 over 2. You flip it over, you fix it, you end up with negative root 2. Shelby, how about the cosecant of negative 5 pi over 3? Yes. So you back all the way up into the first quadrant. You flip the sign, you fix it. Good. Fernando, how about number 9, the cotangent of negative 4 pi over 3?
Negative
squared over 3.
Negative square root of 3 over 3. That's what you meant to say. Yes. All right, 3 more. Do the last 3. How do you handle 13 pi over 3? You can minus 2 pi to back up. So I don't know where 13 pi over 3 is, but if I back up 2 pi, back up 2 pi, that would put me at 7 pi over 3. Some people might know where that is, and they would just stop there and know what quadrant that lands in. Other people are like, wait a minute, that's bigger than 2 pi. Let's back up one more time and land at pi over 3. And the fancy word for those two angles is coterminal. So I'm at pi over 3, and I want the cotangent of that spot. So basically, we're add or subtract 2 pi over 3 to all of these until you get something, not 2 pi over 3. Add or subtract 2 pi to get to land wherever you need to land. About the cotangent of 13 pi over 3? Root 3 over 3. I like that answer. First quadrant, so it's got to be positive. Flip the tangent. Yes, root 3 over 3. Tanner, secant of 23 pi over 4. What'd you get for that? Square root 2. I like that answer. It ends up being in the fourth quadrant. In the middle, you flip the cosine, and you get root 2. Yes. Hayden, you got, in some sense, a hard one, but once you figure out kind of the pattern here, it's just 0. Because 50 pi is how many times around? It'd be 25 times around, so I'm not going to draw all 25, but 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, and so on. You keep landing there, so the sign of there is 0.